Hello, good evening students. In previous class we have studied some basic advantages of three-phase induction motor and constructional view of three-phase induction motor. The main parts of an induction motor are three. Number 1 stator, number 2 rotor, number 3 air gap. Once again, stator is a stationary part of machine, rotor is a rotating part of machine. In between stator and rotor there is some gap, it is called as air gap length. All three are important aspects of design and which impacts on performance of motor. Today we have to study basic working principle of three-phase induction motor. So once again you have to consider the stator and rotor are symbolic representation. Top circle represents stator, below circle represents rotor. There is a air gap between stator and rotor. Whenever three-phase AC supply is given to the stator winding, there is a production of magnetic field. Three magnetic fields are produced. Hence, resultant one magnetic field is developed, which has a constant magnitude, which is rotating at a synchronous speed over the rotor conductor. The synchronous speed of rotating magnetic field is given by Ns. Ns equal to 120 F by P, where F is known as supply frequency and P is known as number of stator poles. Less number of poles, high synchronous speed and vice versa. This rotating magnetic field splashes over the rotor conductor. Hence, this rotor conductor cuts the magnetic flux. This rotor conductor cuts the magnetic flux. An EMF is induced. As shown in figure 2, there is rotor conductor surrounding an EMF is induced, that is known as rotor induced EMF. Figure 1 represents there is a production of rotating magnetic field which rotates at the synchronous speed. It is imaginary part. It is imaginary part. When the rotor circuit is closed, rotor current will flow. This induced rotor current has a such direction as per Lenz's law. It opposes the cause which produces it. Hence, this rotor induced EMF causes the rotor induced current in the rotor circuit. The figure number 3, effect of rotating magnetic field and rotor induced EMF. Hence, the current carrying conductors are placed inside the magnetic field. A torque is developed, a force is developed, hence which starts to rotate in the same direction of rotating magnetic field. It tries to catch the rotor starts rotating. This is known as rotor speed of motor. It is also referred as motor speed. It is referred as n RPM. It never catches the synchronous speed Ns of rotating magnetic field. This is working principle of induction motor, which is similar to working principle of transformer. The stator and rotor are electrically separated, similar to primary and secondary winding of transformer. The induced EMF in the secondary winding is due to mutual induction in the transformer. In the same manner, the induced EMF in rotor by mutual induction. Hence, the basic working principle is mainly based on mutual induction as per Faraday's laws of electromagnetic induction. Sir, try to understand. Same points you give here. When three-phase AC supply is given to three stator windings, three stator currents IR, IY, IB flows through stator windings. Each stator current produces a magnetic field. Hence, there are 3 stator windings, 3 individual magnetic fields have been developed. Effect of all 3 magnetic fields, one resultant magnetic field is produced, which has a constant magnitude. It rotates at a speed of synchronous speed. This synchronous speed ns equal to 120 f by p, where f is supply frequency, p is number of poles. This rotating magnetic field has a constant magnitude and which rotates at a synchronous speed over the rotor conductors in the gap. Hence, this magnetic field splashes over the rotor conductors. Hence, the rotor conductor cuts the magnetic field. The rotor conductor cuts the rotating magnetic flux. Hence, whenever a conductor cuts the magnetic flux or whenever a conductor links a changing flux, an EMF is induced as per the Faraday's laws of electromagnetic induction. Hence, an EMF is induced in the rotor conductor and there is no electrical connection between stator and rotor. Electrically, both stator and rotors are separated. It works on mutual induction as per Faraday's laws of electromagnetic induction. If the rotor circuit is closed, then the induced rotor current will flow in the circuit. The direction of induced current of rotor is such that as per Lenz's law, it opposes the cause which produces it. What is the cause to induce the EMF in rotor? The effect of rotating magnetic field. Hence, to reduce the effect of rotating magnetic field, rotor starts rotating with a speed n rpm. This is also called as motor speed because it is physically available. Rotating magnetic speed of the magnetic field in the air gap, it is a imaginary concept. Try to understand. When 3-phase AC supply is given to stator, due to 3 stator currents, a resultant magnetic field is developed which rotates at the synchronous speed. It is imaginary part, it is not visible, but actual rotation of rotor or motor speed which rotates at n rpm, it is we can observe. The speed of the motor is always less than speed of the rotating magnetic field ns, that is n is always less than ns. The difference between synchronous speed of rotating magnetic field and actual speed of motor is called slip. This slip depends upon load condition on the motor. As the load goes on increases, speed goes on decreases. As the speed goes on decreases, this slip is increasing. Hence, the slip speed may be estimated by the difference of ns minus n, sir, or the fractional value of slip may be calculated ns minus n divided by ns. So, next we have to solve simple problems on slip calculations. Just 2 steps you are going to gain 6 marks. A 3-phase 4-pole 400 volts 50 Hz induction motor runs with a speed of 1440 rpm. Calculate its slip. First you try to observe the data and write down given data at one side. What are the given things? Number of poles P equal to 4 is given, 1 point. Second point, frequency is given, frequency f equal to 50 Hz. Motor speed is nothing but rotor speed. Motor speed n equal to 1440 rpm. Hence, So, we are already knowing how to calculate synchronous speed, then slip. Step number 1, synchronous speed ns equal to 120 f by p. Sir, you substitute frequency f equal to 50, number of poles equal to 4, calculate ns. ns equal to 1500 rpm, that is revolutions per minute, unit of speed. After calculation of ns, step number 2, go for calculation of percentage slip. Percentage slip equal to ns minus n divided by ns into 100. So, you are knowing ns 1500, you are knowing n as 1440, substitute value, then we are going to get as slip. So, slip is in fractional value, it is 0.04, sir, or 4%. You keep both answers, slip equal to 0.04 or 4%. This problem can give 6 marks. Then go for second problem, sir. A 8-pole alternator runs at 750 rpm and supplies the power to a 6-pole induction motor which runs at 970 rpm. What is the slip of induction motor? So, you observe very carefully, draw the diagram, understand the depth of problem. In previous problem, frequency is given, we went ns, we went slip, but here frequency is not given, frequency is indirectly given. Sir, we have to understand alternator means AC generator. AC generator generates 3-phase AC power and it is connected to 3-phase induction motor. It is connected to 3-phase induction motor. What is the AC power generated by the alternator or AC generator? With that frequency, it supplies the power to induction motor. Hence, we have to calculate frequency from alternator data, that is only one additional. Remaining all things are same. Sir, remaining all things are same. You write down the data, alternator poles PA equal to 8, speed of alternator NA equal to 750 rpm, don't confuse. After that, induction motor data, you write induction motor data, number of poles P equal to 8, frequency of induction motor, this is again we have to calculate, that should be 50 hertz, we have to calculate that. So, we are having a standard equation, frequency of generated EMF, F should be equal to P into N by 120. To avoid the confusion, we have taken PA, poles of alternator, NA, speed of alternator, that denotes. Hence, you have to take poles of alternator 8, speed of alternator 750 rpm. Hence, you calculate frequency, that F equal to 50 hertz. This is only indirect. Rest of problem goes in same manner. So, frequency of induction motor becomes frequency of generated EMF of alternator. Therefore, alternator generates the EMF and supplies to motor. This all. Frequency of alternator is also same, frequency of motor is also same. Hence, frequency of induction motor is 50 hertz. Then note down the data of induction motor, number of poles 6, frequency of motor 50 hertz. Then go for second point, synchronous speed you calculate, synchronous speed of induction motor, keep in mind ns equal to 120 f by p, f of motor 50 hertz, p poles of motor 6. So, we are going to get ns equal to 1000 rpm. Then go for calculation of slip, percentage slip equal to ns minus n divided by ns into 100. So, 1000 minus 970 divided by 1000 into 100. So, you are going to get as 3% or 0.03. Here it is printed as n. Don't confuse. Slip equal to ns minus n divided by ns. You make that small correction. So slip may be 3% or 0.03. Thank you to one and all. So we are having another one or two type of problems on slips. All problems are asked in VTU examination for 6 to 8 marks. Only 2-3 steps. Practice. You try to get all 8 marks. Thank you to one and all.